Greetings. Today we are presenting to you our PBL topic, which is Theoretical Analysis and 3D Model of Ackermann Steering System. Our group consists of Milan Chaudhary, Tarun Pachori, Vipan Singh, Nihal Shetty, and Pranay L. Mulepati. We have done calculations based on force analysis on the chassis structure. Force analysis. An analysis yielding the respective forces acting at any point of any member or part of a member of a mechanism obtained by using relationships for dynamic equilibrium in a plane rigid body subject to external forces within this plane and to internal forces due to its motion in this plane. Analysis of Ackermann steering mechanism. Ackermann steering geometry relates the steer angle of an inside tire to that of the outside tire. When turning, the inside tire travels a shorter radius than the outside tire, and thus must have a greater steer angle to avoid tire scrub. Classic Ackermann minimizes scrub by positioning both tires perpendicular to the center. It can have a significant impact on the tire wear. Ackermann analysis can also be used as a tuning tool in cases where classic Ackermann may not be the objective.
Hey everyone, this is Milan Chaudhary. In this video, I am going over the Ackermann steering. The name Ackermann comes from a guy named Rudolf Ackermann who actually patented this idea. Back before the Ackermann steering was around, some of the tire may slip because they have come to a different point. The Ackermann steering, the reason it exists is your tire do not slip when you go around a corner. Now, how you achieve this is by having a central point at which all your tires are rotating around. So you can see the angle of inner tire is greater than the outside tire. With the angle being greater, they can come to a central point, and then all four tires can rotate around one point, which means tires do not have to slip as they go around. If both tires are on the same angle, then they have to slip around some uncommon point. So it wouldn't work as well, especially at high speed. The Ackermann principle is great for solving this problem. The one thing we have to see when we look at this is each tire has a path of different radius. Now what that means is that all tires are rotating at a different rate. One at the outside travel further distance than one at the inside in the same amount of time. So it's rotating more quickly. Now what does this mean? This means right side is moving faster than the left side when we are going left hand turn, and vice versa if we are going right hand turn. Also what this means is the front tire, because it travels greater distance, as you can see, than the rear tire, they are moving faster than rear tire when you turn. This is the real reason you need a differential in rear tire, so that you can split the speeds between the front tires and the rear tires. Otherwise, you're gonna have understeering or slipping. Now the important points of having the Ackermann steering in your vehicle. First is the right side tire moves faster than the left side tire in the left turn, and left side tire moves faster than the right side tire in the right turn. Also, front wheel moves faster than the rear wheel at any turn. It also prevents tire from slipping, and it also provides better cornering.
Hello, myself Vipan Singh. I am going to explain the advantages and disadvantages of Ackermann steering system. The advantages of Ackermann steering system are: it has ultimate cornering ability, it has high turning radius, and it has improved steering response. And disadvantages of Ackermann steering system are: it increases the weight of vehicle, and it also increases the cost of the vehicle. Its linkages are extremely complicated.
Greetings to everyone, I am Tarun Pachori. Hereby I will be providing a brief explanation to the calculations we have made in studying the design of chassis members in accordance to the Ackermann steering design that has already been explained. Without wasting much time, I would like to draw your attention to the assumptions we have made based on already existing vehicles. We have taken the mass of the high performance vehicle to be 126.03 kgs, which will be 1.2 tons in weight, and the average velocity to be 60 km per hour, that is 16.67 meters per second. Here we have considered the chassis member to be a uniform circular rod made out of C40 steel and having an FOS of 1.5. The chassis member in the front wheel section are subjected to both axial and bending loads, wherein the inner wheel is subjected to axial tension and the outer wheel is subjected to axial compression. Using the concepts of design of machine elements 1 pertaining to members subjected to combined loading, we were able to conclude that the diameter of chassis members to be used should be 44 mm when the inner front wheel is taken into calculation perspective and 41 mm when the outer wheel is taken into consideration respectively.
Greetings, I'm Pranam Revati. Continuing with the determination of the dimension of the chassis members of a vehicle which operates on Ackermann steering mechanism. Beams of chassis connected to the rear wheel are perpendicular to the direction of the centripetal force resulted by the turning of the vehicle. So those members are subjected to bending stress only, unlike members connected to the front wheel. Considering all the previous assumptions made and applying concepts of design of machine components subjected to bending, diameter of the chassis member connected to the outer rear wheel was determined to be 45 mm and that of inner rear wheel was determined to be 50 mm. Since the stress at any location shouldn't exceed the design stresses adopted, diameter of the chassis members of a vehicle shouldn't be less than 50 mm.